Okay, Math 2, Section 10.2, we're talking more about exponents and specifically negative exponents and division. So anytime you have a negative exponent, it ends up changing the side that it's on. Okay, if you're simplifying though and you get a negative exponent, you would write it as a fraction and it is in the bottom, in the denominator of the problem. Okay, and so when we go to these examples, first of all, exponents belong to whatever they're touching. So this -1 belongs to the 2. Make sense? And so since you have a negative exponent, we're going to end up writing this as a fraction, and so it'd be 1 over 2 to the first power, but we don't normally write the first power. If you want to write a 1 there, you can. It's just not necessary. Okay, so on example 2, how would I end up writing 5 to the negative second power? Good, I'm going to make this in 2 steps, 1 over 5 to the second, which is really 1 over 25. Okay, because 5 to the second power, 5 times 5, 25. Okay, example 3. Now remember what I just said about the exponent belonging to anything it's touching. Do you see here how this -2 exponent is touching these parentheses? So that means the -2 exponent belongs to the entire parenthesis. So when I write this, we're going to do this in multiple steps here. We go 1 over and keep it in parentheses, 3x to the second power. And then we're going to simplify. So we end up with what? Good, 1 over 9x squared, because that 2 power or exponent goes to both the 3 and also to the x. Yes? That is the whole reason why I put it to the bottom, is because when you move it from one side to another, it gets rid of the negative exponent. So right now, this is, you can think of it as a fraction over 1. Well, to get rid of the negative exponent, you switch it to the opposite side. Okay? Now, on number 4, notice the difference between 3 and 4. The -2 is only touching what? The x, which means, how would I write this answer? Very good, 3 over x squared. So the 3 didn't have a negative exponent, so it would stay on the top of the fraction. And again, you can write these over 1. So the 3 stays on top because it doesn't have a negative exponent, where the x does have a negative exponent, and that changes to the denominator. Okay, do we have any questions right now? When you change the side, a negative exponent changes from negative to positive, right? And it could be vice versa if you wanted. Okay? All right. We have talked about this a little bit already, but just remember that when you have a parenthesis, that exponent goes to everything that the exponent is touching. So when it's touching a parenthesis, it goes to each term inside. Okay? So even if it's a fraction, it goes to both the top, the bottom, everything. All right, moving on. So example 5 here. Again, notice how this exponent of 2 is touching the parenthesis. So that means that this 2 goes to the 4 and also to x to the 3rd. So when let's write this out. So we have 4 to the second power. And then what do you do with powers to powers? Do you guys remember? Multiply them. So that will be x to the 6th, and then 4 squared is 16, so my answer is 16 over x to the 6th. Okay, I'm going to give you a minute to do number 6, and if you can simplify, you would simplify as well. Okay, so this exponent of 2 is touching the parenthesis. So that means it's going to go to both the 5 and the x. So what do I end up with on the top to start with? Okay, 25x squared, and that's over 10. Notice that the 10 wasn't in the parentheses, so the 2 does not go to the 10. And then can this be reduced? What can we divide both of them by? 5. So 25 divided by 5 is 5. 10 divided by 5 is... So my final answer is 5x squared over 2. Okay, any questions there? All right. So this next part, it says you can use repeated multiplication to simplify quotients of powers with the same base. It says expand the numerator and denominator, then divide out common factors. Okay, so we don't normally do this, but they're showing you if you have 4 to the 5th divided by 4 to the 3rd, you could write out 5 fours and 3 fours, and they cancel out 1 for 1. So like these cancel, these cancel, these cancel, and you end up with 2 4s left, which is 4 to the 2nd power. Now, the shortcut is that we could have just subtracted. So 4 to the 5 minus 3 makes 4 to the 2nd power versus writing everything out. So remember, when we're multiplying, we are adding exponents, but when we're dividing, we are subtracting exponents. Okay? So we're just going to kind of make a little note to ourselves to remind us. So division, subtract exponents. Okay, and then when we have multiplication, we add exponents. Okay, I want us to make another note here, and that is that negative exponents go to the denominator. If you don't remember it's the denominator, you can put bottom and change to positive. Oh my goodness. Okay, positive exponents I'm going to put go to the numerator, which is the top. So again, negative exponents go to the denominator, bottom, and change to positive. Positive exponents go to the numerator, top, and they stay positive. So what I normally do is just write these all as kind of like separate problems. And I usually do them in alphabetical order. And so do you see on example 7 how we have J's and K's? Okay, so I start with J's. So we have J, and I'm going to go 2 minus 5. What is 2 minus 5? Negative 3. Okay, so wherever they are, you always go the top minus the bottom in the exponents. Okay, now we go to the K's. On K, we have 6 minus what? 1, which makes 5. Okay, so is everybody okay with what I've done so far? So all I've done is taken each of these exponents, and I always do the top minus the bottom. But they have to be like bases. So I do my J's separately from my K's. Now, over here, we're going to write these as a fraction. Do you see how J to the negative 3rd? It's a negative. So that's going to go to the denominator and become positive. So on the bottom, I'm going to have J to the 3rd power. K to the 5th is positive. So that is going to go to the numerator and stay positive. And that's my answer. Okay, do you have questions? Okay, we're going to do 8 together, and then you're going to try 9 on your own. So again, I take each piece of the problem kind of separately. So starting with the numbers, we have 6 divided by 3, which will reduce to what? 2. Okay, then we go to our a's. Always start with the top and then subtract the bottom. So that means I'm going to have negative 3, what? Minus 5. And what is negative 3 minus 5? Okay. Then we go to the b's. And I have 7 minus 2, which is 5. Okay. So now we're going to write this. Now, no matter what your number is, if it's a fraction or a whole number, so this is the 2 is going to be on top. Is everybody okay with that? If I had 1/2, I'd have a 1 on the top and a 2 on the bottom. Okay, you could put a 1 on the bottom if you want to, but that's not necessary. And then where is the a going to go? Very good. And so we get rid of the negative when we move it to the bottom. So that's going to be a to the 8th now. And then where does b to the 5th go? Top. That's it. That's it. Okay, are you guys ready to try 9 on your own? Does anybody want to ask me questions about 8 before trying 9? Okay, so once you have your answer to number 9, raise your hand and I will check it out or check in your groups. That's it. Got it. So check the rest of your group.
Yeah, Robert, you can get it right.
Check the rest of your group, okay?
C8. C8.
That's it. Check the rest of your group, okay?
It's a lot of numbers.
Okay, from everyone I checked, everybody got the correct answer for the most part. So I'm going to go through this just in case some of you did not get it. Ask questions if you have them. Starting with the numbers, 12 divided by 4 reduces to 3. Then we go to our a's. You always start with the top. So I have negative 1 minus 5. And what is negative 1 minus 5? Negative 6. Then we go to the b's. This one was tricky for some of you. You have 6 minus a negative 1. What happens when you have minus a negative? You have to add them. And so we get b to the 7th. For the c's, we have negative 3 minus 5, which makes a negative 8. Okay, any questions here? So when we go write this as a fraction, the 3 is going to be on top. Now, because a is negative, it's going to go to the denominator and become positive. So we have a to the 6th power now, the positive 6. B to the 7th will be on top because it already is positive. And then c to the negative 8 will go to the denominator. And when you move it to the denominator like that, it becomes positive. And so this is my final answer. Are there any questions there? Okay, we're going to go ahead and move on to the next page. Okay, so you know with negative exponents how we end up changing the sides. Okay? If you have a fraction raised to a negative exponent, you could distribute the negative exponent through here. But then in order to make the negative exponent positive, you would end up then changing the sides of both of them. So with a fraction, it is easier to just, when you have a negative exponent, you flip your fraction and you make it a positive exponent. Okay? So we're going to make a little side note here to ourselves. Okay, so if you have a negative exponent with a fraction, thank you. So negative exponent with a fraction, flip the fraction, and change exponent to positive. Then simplify. Okay, are we ready? So, starting here with example 10. Okay, because of this negative exponent, if you ended up putting the negative to both of these things, you'd end up having to change sides anyways. And so the easier thing to do is to flip your fraction. So we're going to write this as 5b over a. And then when you flip it, you're able to then make that a positive 2 exponent. So anytime you have a negative exponent, it ends up changing sides. Well, since that's a negative touching the parentheses, that negative exponent goes to both. And so we're able to just change both of them and make that a positive. Now what will I do next? Simplify, and we'll do that by taking that exponent of 2 to everything in the parentheses, because our exponent always goes to everything it's touching. So we end up with 5 to the second power, b to the second power over a to the second power. And then we would end up making 5 to the second power 25. So 25b to the second over a to the second. Okay. Any questions before we move on? Okay, number 11. I'm going to give you about 30 seconds to a minute to give this one a try. Once you get the answer, check in your groups. Okay, what would be my first step? Flip it. Very good. So everything in here and the negative, it doesn't really matter. This negative can just stay out in front how it is. So we flip the fraction, and you should have 3y to the third over 2x to the fourth. And then that changes it to a positive power of 2. Is everybody okay with that? Now remember, this 2 now is touching the parentheses, so it goes to everything inside. Well, what happens when you have a negative times a negative? It makes a positive. Okay? So that's going to become positive, and then we have, and I take this one step at a time, 3 to the second power, and we can go ahead and just write that as 9. Okay? Y to the third raised to the second power will make y to the, very good, 6 is correct, over. Then we have 2 to the second power, which is 4, and then what happens there? X to the 8th. Can anything reduce here? So that's my answer. If you end up with any negative exponents anywhere in here, you can get rid of negative exponents by changing the side that it's on. Okay? You want me to say that again? So let's say you ended up with like x to the negative 8th. You don't want a negative exponent, and so the x to the negative 8th would end up moving to the top to make it a positive 8. So when you like simplify, you know how we flipped it and everything, sometimes you'll still end up with a negative exponent, and whatever side the negative exponent is on, if you change it to the opposite side of the fraction, it changes from negative to positive. Okay? All right, let's go on to number 12. Okay, what is the first thing I would do here? Very good. Flip the fraction. Okay, so we get 3x to the 5th y over, oops, I did not flip it. Okay, let's try that one more time. Okay, so we're going to get negative 6 x to the 6th y to the 3rd on top over 3x to the 5th y in the denominator. And then that negative 2 exponent then changes to a positive 2. Okay, so we just flipped everything and made that now a positive 2. Okay, so now what do I do? We're going to simplify by taking that power of 2 to everything inside the parenthesis. So what is negative 6 squared? Positive 36. We're going to get x to the 12th, because powers to powers we multiply. Good. We're going to get y to the 6th over. We get 3 to the 2nd is 9. Okay? X to the 5 times 2 makes 10. Not a trick question. Okay. And then this one will be y to the 2nd. And you could write a 1 there, and 1 times 2 still gives you 2. Now this one we have to simplify like we did the other problems. Okay? So we start with 36 over 9. What is 36 over 9 reduced to? 4. Okay, then we're going to go and combine our x's. So x to the 12 minus 10 makes x to the what? Very good. X to the 2nd. Okay, with the y's, we have y to the 6 minus 2, which makes what? 4. Y to the 4th. Now, do any of those have negative exponents? No. So my answer will just be 4x squared y to the 4th, and nothing will be in the denominator because none of the exponents were negative. Are we good? Yes.
Did we do that? 36 over 9?
Yeah, so we started with the numbers and we reduced the numbers. And then we reduce, see how you have x's on top and the bottom? You always just want them in one location. So you have to like put all the x's together. And since it's a fraction, when we're dividing, we subtract. And so we simplify the x's and we simplify the y's. Okay? Since none of the exponents ended up being negative, everything stayed on the top, so you no longer have a fraction. Well, you do, it's just over 1. Okay? All right, 13. Okay, so what's the first thing you would do on this problem? Am I going to flip anything right now? No, because I don't have like a negative exponent outside of this parenthesis that I would need to like change the side on it. Okay? And so I'm going to start by just rewriting our numerator, rewriting the top. And then I'm going to go to the denominator and I'm going to take this 2 exponent and bring it to everything inside. So what is negative 2 to the 2nd power? A positive 4. Okay? X to the negative 2 is going to become x to the what? Negative 4, right? Because negative 2 times 2. Okay? We're going to get y to the 2nd and then z to the negative 2nd. Is everybody okay with what we've done there? Okay? And we understand I didn't change anything on this one because this 2 exponent was positive. I only changed them when it was a negative exponent. Okay? So now I'm going to go through and simplify right now because I have x's to put together, y's to put together, z's to put together. So starting with the number, 4 divided by 4 reduces to what? 1. Okay, for the x's, what will I write? What exponent is here? On top. It's a 1, right? And so we're going to go 1 minus, and this one's a -4. So what does that end up equaling? Very good. X to the 5th. Okay? For the y's, I have -2, and then what? -2. What is -2 minus 2? -4. Good. And the z's, what exponent does this one have? A 1. So we get z to the 1 minus a -2. What's 1 minus a -2? 3. Does anybody need me to re-explain anything that I did here? Okay, so do you see I have some negative exponents? That means this one is going to end up having a fraction, right? So on top we have 1. Do I need to write 1? No. But you can if you want. Okay? X to the 5th, where is it going to go? Top or bottom? Top. Y to the -4th, where is that going to go? Bottom. And when we put it to the bottom, it is a positive. And then where does z to the 3rd go? And that's my answer. It is. That's it. Right there. Okay. Questions? Okay, are we ready for 14? Very similar to 13, except for... Okay, now the one thing is that there are multiple ways of doing these problems. Okay? Now, when we have negative exponents, especially when you have a number with a negative exponent, I feel like it gets sometimes confusing. So do you see how this whole parenthesis has a negative exponent? If I take this whole parenthesis, just like how we did with the fractions, I can take the whole parenthesis, move it to the denominator, and when I do that, it changes that negative exponent to a positive. Okay? So I'm going to go ahead and move that. So I'm going to rewrite this problem. I still have 3c to the -3 and f to the 3, and this is raised to the 2nd power. And then this one, I'm going to put it on the bottom, and I have 6c to the 4th, f to the -3rd, because I was only, when you're switching sides, you can only take care of one exponent at a time. And so it's just taking care of that negative exponent. Nothing inside changes. Okay? So when I take that parenthesis, move it to the bottom, it's only taking care of that -1. So now I'm going to go through and try to simplify. But notice that these are being multiplied right now. Do you see how they're all on the same side? Okay, so this changes things a little bit, so we need to be careful. So we're going to start with our first parenthesis, and we're going to take this 2 through here. What is 3 squared?
That is 9.
Very good. Okay, and this is going to be c to the -6. Good. And we get f to the 6th. Good. And I'm just going to rewrite this parenthesis right now because the exponent of 1 doesn't change anything, right? And so we just have 6c to the 4th, f to the -3. Now this goes back to what we learned last time, and that is when they're multiplying, what do you do with the exponents? When they're multiplying, you add them. Okay, so these two are both on the bottom of the fraction, and so that means we add the exponents. Okay, we multiply the numbers, but we add the exponents. So 9 times 6 is what? 54. I'm going to write out each of these separately. Okay, so we have c to the -6, but because they're multiplying, I'm going to add 4. And what does that make? C to the -2. Okay, and then the f, I have 6 plus a -3. Or I'm just going to put 6 minus 3. And what does that make? F to the 3rd. So how will we end up now writing this answer? You have to be careful, okay? So in fact, you might even want to write this as 1 over, and we have 54c to the negative second f to the third. We have to be careful with this is because when we were simplifying this, everything is on the denominator that we're simplifying. Okay? So this negative, we have to get rid of it, and we have to switch the side. And so that one's going to end up going to the top. Okay? So when you just have to be careful on some of these. So we end up with c squared on the top, and then 54 f to the third in the denominator. Okay, and the reason why I was like this is because I was simplifying what was in the denominator. Okay, so what I simplified here was in the denominator. Okay, and then we have to switch the side if we get a negative exponent, so it changed from being in the denominator up to the numerator or the top. Do you have any questions for me? Okay.